Find the derivative of g of x equals the cubed root of x cubed plus 2x times 3x squared plus 5 to the 3 halves. So g of x here is a product rule of two functions. We have the cubed root of x cubed plus 2x times the 3x squared plus 5 all raised to the 3 halves. And therefore, we're going to make use of the product rule. But before we do that, let's rewrite that cubed root of x cubed plus 2x as a fractional exponent. It's first power, third root, so 1/3 power. And we'll leave the 3x squared plus 5 to the 3 halves alone. Now, overall, we have the product rule. So our derivative g prime of x will be the first term, bring down the power, so that'll be a 1/3. Leave the inside alone, so we'll have x cubed plus 2x to the 1/3 minus 1. We subtract 1 from the power. I'll call it 3/3. Multiply by the derivative of the inside to complete the chain rule. That'll be a 3x squared plus 2. That's all the derivative of the first times the second left alone, which is a 3x squared plus 5 to the 3 halves power, and then plus the first left alone, which is the x cubed plus 2x to the 1/3 power, times the derivative of the second, which is a power rule. We'll bring down the 3 halves. We'll leave the inside alone, 3x squared plus 5. Subtract 1 from the power. I will call it 2 halves. And then multiply by the derivative of the inside to complete the chain rule. Derivative of the inside is 6x. So our g prime of x equals, I have a 1/3, I have a 3x squared plus 2, I'll write that next, since that doesn't have a fraction exponent. I have the x cubed plus 2x, that's this term, raised to the 1 minus 3, negative 2/3. And I have the 3x squared plus 5 to the 3 halves. I have, in the next term, constants of 3 halves and 6. I can multiply those, and that'll give me 3 times 6 is 18 divided by 2. That'll be a 9, 3 halves times 6. I also have this x. I'm going to put that out front. I have the x cubed plus 2x to the 1/3 power, and I have the 3x squared plus 5 to the 3 minus 2, 1/2 power. We're going to want to factor this expression. And one of the things we'll need to factor are the constants. And right now I have one of them is over a 3, and the other constant, that one, the 9, is not over a 3. Well, we need to get them both over a 3, so I can factor a 1/3. So what we'll do is multiply the 9 by 3 over 3. Everything else is going to stay the same. So I will just recopy everything else exactly as we see it. Except I'm going to write this 9 as a multiplied by 3 over 3, a 27 over 3. And that way we now have a common denominator between those terms, so we can factor out that 1/3. That's going to be part of our factoring. All right, so there's the entire expression with the 27/3. So we can factor now, and we can factor out the 1/3. And that just means we won't have a denominator anymore under each of our constants. Actually, this first constant, if you factor out 1/3, will be a 1. Everything else will stay as is. This will be a positive 27. The next thing we're going to do is start to factor out powers of expressions. So g prime of x is now, we have a 1/3, and we can factor out, let's start with the x cubed plus 2x. We have that raised to a negative 2/3 power in the one term and raised to the positive 1/3 in the other term. You can factor out the lower power of the two. Well, the lower power is the negative 2/3. So I'm going to factor out a negative 2/3 from here. Factoring out a negative 2/3 means you're subtracting a negative 2/3. You're dividing it out when you factor. And division means subtraction of exponents. So we're going to be subtracting the negative 2/3 that we're factoring out. Well, subtracting a negative 2/3 is equivalent to adding a 2/3. So you're going to end up adding a 2/3 to this power. That'll make that become a 0 power or a 1. And so all of that is getting removed. And you're going to add a 2/3 to this power over here. And 1/3 plus 2/3 is going to become a 1 power. And so we're going to have that to the first power. And there's what we're going to have left over after we factor that out. So we will have a 3x squared plus 2. We fully factored this, so that's gone, times a 3x squared plus 5 to the 3/2. We have plus a 27x, and this, when we subtracted a negative 2/3, it became a 1 power, so we just have the x cubed plus 2x, and then we have the 3x squared plus 5 to the 1/2. Now in our next step, we're going to be able to factor out powers of 3x squared plus 5. We have a 3/2 power in the first term, and we have a 1/2 power in the second term. We can factor out the lower, which is the 1/2 power. So g prime of x will be 1/3 x cubed plus 2x to the negative 2/3. I'm not doing anything with that. And then we're going to factor out the lower power of 3x squared plus 5, which is the 1/2 power. Remember, factoring means subtraction, and so we're going to subtract the 1/2 from this one. Well, 3/2 minus 1/2 is 2/2 or 1. So that's just going to become a 1. And we're going to subtract it from this power over here. Well, 1/2 minus 1/2 is a 0 power, and anything raised to 0 is a 1, so that whole thing is being factored out. There's what we're going to have left. So we're going to have a 3x squared plus 2 times a 3x squared plus 5 to the first power, plus a 27 times x cubed plus 2x, and then all of this was factored out, so that's gone. And close that bracket there. So g prime of x now equals 1/3 the x cubed plus 2x to the negative 2/3 times 3x squared plus 5 to the 1/2. And then in the square brackets, I'm going to FOIL this out. First, 3x squared times 3x squared is 9x to the 4th. Outside, 3x squared times a 5 is a 15x squared. Inside, a 2 times a 3x squared is a 6x squared, and then last 2 times a 5 is a 10. And then I'm going to distribute this in here, and a 27 times x cubed is 27x cubed, and a 27 times a 2x is a 54x. We can combine the like terms together within there. So we will have a 1/3 x cubed plus 2x to the negative 2/3, a 3x squared plus 5 to the 1/2, which we can always write as square root of 3x squared plus 5. 1/2 means raised to the 1 and then second root or square root. And then in the square brackets, combine like terms. There's only 1x to the 4th, so 9x to the 4th. There is only 1x cubed, so 27x cubed. There is two x squared terms. 15 plus a 6 is a 21 x squared. We have one x term. It's 54x, and then I have one constant. That's a 10. The last thing to do is we can move this negative exponent to the denominator with the 3, and the numerator is going to be made up of everything that's left over, the 1, that square root, and that big expression in parentheses. And there's the final result for this. So this is going to give us in the numerator, we will just have left over, since 1 times anything is the same thing, the 3x squared plus 5, and the square root, the big expression 9x to the 4th, 27x cubed, 21x squared, 54x plus 10, and then all of that over. And in the denominator we have a 3 that's already down there from the 1/3, and then we just move the x cubed plus 2x, and it will now be to a positive exponent. That's why we moved it. It'll be to the positive 2/3. There's our derivative, g prime of x.